First of all, I would like to thank Stephanie Moulton for inviting me to give a talk of my latest book, which is out of Oxford University Press on Indian cities or suburbs. And is Stephanie there? I would like to just congratulate her on her membership into the class of 2025 Fellows of NAPA, the National Academy of Public Administration. And I just wanted to start this talk by saying that this book talk is quite emotional for me for a couple of reasons. One is that I lost my dad late last year in November, and this book is dedicated to his memory. One. And the second thing is that I graduated under the guidance of Chuck Adams at Ohio State. I mean, he was at the John Glenn School. It was a school then, and Chuck passed on last year in May. So I really I miss him a lot in all my academic endeavor because I used to share all these tidbits with him. And his wife Connie promised that she would be here. Maybe she'll try and join a bit later. I don't know. And so those are the two things emotionally related to this talk I'm giving. And the third thing I want to say before I actually start this talk is that this book is an outcome of my Fulbright Fellowship at UCLA in 2021 and 2022. So I worked on this for nearly 3 or 4 years. So I was really happy to see this book see the light of the day this year in June out of Oxford University Press. So, this book is titled Indian Cities or Suburbs and Trends and Causes of Suburbanization. Well, in reality, I also cover the consequences of suburbanization in India. And so Oxford could not accommodate that last minute change in the title. And so it stopped at trends and causes of suburbanization. So now what I would like to do is move on to the next slide. Okay. These are the research questions and objectives that led me into the investigation of this research for the book. Um, Basically, this book is about India's cities and urban areas. So, the first research question that this book attempts to answer is whether India's population and households sprawl. I mean, sprawl is a much more haphazard word than suburbanization, but for the moment, we will try and use them interchangeably. And did they sprawl during 1975 to 2015? And that is the first research question. The second research question that I try to answer here is whether or not jobs in urban India are suburbanized and whether the job suburbanization is the same as that of population or households. And are there regional variations in the population or the employment suburbanization of India's cities? And what are the factors with associate with population suburbanization in India's cities? And what are some consequences of suburbanization? I just saw Stephanie. Hi, Stephanie. I just thank you
Oh,
for inviting me to this colloquium series. And I just thought I saw David Landsbergen. Hi, David. Nice to see you. He taught me. Dave Landsbergen taught me. So nice to see you all.
yes.
Feels
Thank you for
back.
joining us. Yeah, sorry I
Yeah,
didn't get to
yeah.
you. I was running from another meeting, but it's
No,
lovely to
no,
have
no problem. Yeah, no
super
problem. And I
excited to
also
have an alum of our
I'm sorry.
program back to talk to us. So yes.
Yeah, yeah. And congratulations on your membership into the class of 2025 fellows of NAPA.
Yeah, thank you.
Really.
Yeah.
Yeah, that's great.
And so did you have Professor Landsbergen as a student?
Yes,
Ah,
David Landsbergen taught me. I did not work
wonderful.
under him. Yeah, I did not work under him, but he taught me, and it was very, very interesting. And so excited to see his name. I did not see him actually. And I just started off with an emotional note about Chuck Adams, under whose guidance I worked, and he's no more. And last year he passed away. So his wife Connie promised that she will try and join. So that would be really nice. I don't know if she has joined already, but I really hope she has. And I've
I see
dedicated this
Connie
book to
here.
the.
It looks like Connie is here. So, yep.
Oh, great, Connie. Nice to see you. I don't see you yet, but it's wonderful to have you as a representative of Chuck in this meeting. Really great. Really great. So, continuing on with my book, this is the overview of the book. Chapter 1 is an introduction which summarizes the existing body of work on the subject and points out gaps in the existing body of work that this book tries to address. Chapter 2 talks about the theoretical frameworks, methodology, and datasets that I used. And Stephanie asked me to emphasize this, so I'll certainly talk about it a bit. And chapter 3 focuses on the suburbanization of population and households in India cities. Chapter 4 basically talks about the regional variations in population suburbanization. Chapter 5 is about the job suburbanization of India cities. And chapter 6 explains the suburbanization. Chapter 7 summarizes the qualitative views of experts, academics, realtors, developers, and policymakers on the subject, and tries to corroborate this with the quantitative evidence that I have gathered and analyzed in this book. And finally, chapter 8 focuses in a small way on the consequences of urban sprawl in India's cities. Now, this is chapter 2, excerpt from chapter 2. This is the theoretical framework, and this shows the population density function of a city. And this is the standard urban model. And this graph here might be viewed as one quadrant of a circular city. And on the x-axis is distance from the central business district from CBD, and here is D of R is density at R miles from the city center. And the regression of density, population density on distance from the city center basically yields us the slope of this function, which is our density gradient. So now, how do we define suburbanization in this book? Now, this is a process which is called as B suburbanization. That is a process by which there is a gradual decline in the slope of this density function, which means that there is a decline in the absolute value of the slope of this function. So the graph here shows the density function of two different cities, city 1 and city 2. B1 is the population density gradient of city 1. B2 is the population density gradient of city 2. And you find that city 1 is a lot more suburbanized than city 2, because it has a lower value of the density gradient when compared with city 2, which has a value of 0.8. So this book distinguishes general suburbanization from B suburbanization. B suburbanization is a process of the flattening of the city's density function, right? So have India cities become flat is the title of another article which I've co-authored with Pavo Mankonan at UCLA, who hosted me for the Fulbright Fellowship. So now the B suburbanization should be distinguished from the general sense in which urban economists use the term suburbanization, where holding metropolitan area population constant, there is an increase in the percentage of population living in the suburbs. All right. So that is the general sense in which suburbanization is understood. But here in this book, I use this term B suburbanization very specifically to understand the extent of population, household, and job suburbanization in India's cities. Now, I want to just take a minute to explain the calculation of the population density gradient as opposed to the estimation. The estimation of the population density gradient, as you saw in the previous slide, is a very, very data intensive process, right? Data intensive process in the sense that we need data on the population, the land area to calculate the density, and then you need distances for each of the wards from the city center, and you need to identify a place, central place in the city, which you want to call as a city center, right? So you need data like this for many different pockets in the city for you to be able to estimate the density gradient. So Edwin Mills came up with this two-point gradient technique, which gets around the problem of data availability for a number of different pockets in the cities, right? So basically this green area in the circle shows the entire metropolitan area. The blue inner circle shows the central city, the CBD, right? So RC is the radius of the central city. LC is the population of the central city. L is the population of the metropolitan area. R is the radius of the metropolitan area. So assuming that we have a circular city and we extrapolate the circumference of a circle from a geometry, which is 2 pi r, and we integrate over the density function, which is d of r dr. And in the previous slide here, you know that this is the functional form of the density function, which is a negative exponential, right? So if you integrate over RC, over the radius of the central city, the circumference, you will get one expression like this. And if you integrate over R, the radius of the metropolitan area, you will get the population of the entire metropolitan area. And we use this to integrate over the same 2 pi r, and we use the density function. So what we get here, Mills showed, was the ratio of LC to L, the ratio of population, the central city, to the population, the metropolitan area, which is a function of all known variables except our B, which is the population density gradient, which would otherwise have to be estimated using the regression procedure I showed you in the previous slide. So this is a single equation, single unknown, which can be easily solved for the density gradient. B, because here LC is the population centricity, L is the population metropolitan area, RC is the radius of centricity, RC is the radius of the metropolitan area, all of which are known, and E is just the exponent, which is a constant, and it's only B which is actually unknown, which can be easily solved for using this equation. But we need to remember a couple of caveats about this equation, which can be used to calculate the density gradient, not estimate it, calculate it, that it has no closed form solution, which basically means that there are multiple values of B which will satisfy this equation here, one. Two is also that there is no statistical significance to this, like a regression equation would yield, right? Like the previous slide regression equation would basically yield. And there are no confidence intervals, right? So you cannot really say how confident you are that the estimate will lie in this range. So these are potential problems, but you still get over the problem of data availability using this only 4 data points for every city, as opposed to multiple data points that you require for estimation. So that is the shortcut that the 2-point gradient technique offers for calculating the density gradient. So this is the data and the methodology followed for this research. So I was able to get population, area at the subcity level from this data set called the Global Human Settlements Layer for 1975 and 2015. And we use data for nearly 100 Indian cities, right? For both years, 1975 and 2015. And then the period is very clear why we chose this, because this is the earliest, and at the time of completing the research for this book, 2015 was the latest year for which the data were available. But now my PhD students tell me that it's available for 2024, but after I finished this research. So, and in India, economic reforms happened in 1991. So 1975 is viewed as the pre-reform period and 2015 is the post-reform period. And the opening up of the Indian economy had a lot of implications for urbanization, because farmers had to move away from agriculture towards the cities, because they were not internationally competitive at that time to sell their products in the international market. So this had a lot of implications for rural to urban migration by these farmers, and also for urbanization. So this was a very useful cutoff for us to examine the effect of economic reform on suburbanization also. So now what we did was we estimated population density functions by OLS, by ordinary least squares, in log form, and we drew these population density functions for all these 100 cities as a function of the city center in each of these cities, by choosing one of the city's central points as a center. A railway station, bus stop, state secretariat, or municipal office were chosen as the center of the city, and we drew concentric circles around city centers for each of the 100 Indian cities, right? Each of the 100 Indian cities. And this is for population suburbanization. And for employment and household suburbanization, we were not so fortunate, because we were dependent on data from the Census of India, and where we got data only for about 62 cities from the Census of India. And the Census of India abruptly stopped providing the land area data at the ward level for some reason. So there were a lot of constraints for this employment and household suburbanization. And we also depended on the free download of shape files for cities for which the data were available from the internet, and also from the Census of India. And there is a very senior IAS, bureaucrat in the government of Karnataka, who helped me to get shape files for about 44 cities in Karnataka, of which Bangalore is a capital. So we were able to pull that off. And in addition to using the standard urban model and estimating population density gradients for all of these cities, we also use some qualitative methods, like having a focus group discussion with academics, realtors, policymakers, and developers to understand the extent of suburbanization and what that means for their investments. So I will summarize those things later. So now I hope you're all able to see this. For a minute, I will put this on slideshow mode. Is everybody able to see this? Sophia or someone can confirm this, I hope. So this is a map of India cities with all the 100 cities that we did the suburbanization analysis for. And there are only two kinds of dots here. There is a blue dot, which basically shows the less suburbanized cities between 30% to 82%. And the red dots are the ones which basically sprawled, right? The cities with the red dots indicated by the red dots are suburbanized anywhere from 82% to 99%, right? So, for example, Bangalore is here in southern India, and Mysore is here, and they're all red dots. And this is the South Indian state of Kerala. And most of the cities here are red dots, which means that they were all extensively suburbanized. And there are a lot of blue dots here, which is known to be a very large state but is largely backward and lagging. All blue dots here, right? And this is a very urbanized state and all red dots here. This is again not so urbanized state, but there are some red dots here. So mostly here there are all red dots, right? Near this is the national capital region where Delhi is located, and they're all really suburbanized, right? So this is to just give you a flavor of the geographic extent of the extent of suburbanization that we found and documented in India's cities. So now I told you that we drew concentric circles around city centers for each of the 100 Indian cities. And this is just a snapshot of three cities for which we drew the concentric circles. This is the left-hand most panel is for Delhi, and this middle panel is for Mumbai, and this one is for Bangalore, right? So this is again using data from the GHSL, the Global Human Settlements Layer, which is published by the Joint European Commission in Brussels. So the advantage of this GHSL data is that it is very, very minute, right? It is minute grid level at the 1 kilometer level, right? 1 kilometer level. And we drew concentric circles for every city like this. And you find that Delhi's radius, for example, was 22.5 kilometers in 2015, right? And Mumbai's radius was 30 kilometers, right, in 2015. And you see that for Bangalore, it's a shortest 16 kilometers was the radius of Bangalore in 2015. And these things, you can see that Mumbai, for example, was its radius was only 18 kilometers in 1975, but it became 30 kilometers in 2015, right? So the grayer lines represent the later years expansion. So clearly showing the extent of sprawl of these cities. So this is just for purposes of illustration that I'm showing only these three cities, but we drew concentric circles like this for all the 100 cities that we studied. Now, so what do we find? So this is a summary of the extent of the suburbanization, B-suburbanization of India's cities. And this is for 1975, this for 2015. And we have defined the extent of B suburbanization as a decline in the absolute value of the density gradient. So absolute value means you drop the sign and then look at the number as it is, right? So this is the absolute value, 0.5 is the absolute value of the density gradient in 1975, and it was 0.31 in 2015, which means clearly there was B-suburbanization which happened in India cities during 1975 to 2015. So what does this indicate? This indicates that there was a 50% reduction. So this is a log linear function. You remember when we estimate this in the form of OLS? Um, the log linear function enables us to interpret this as a percentage change. So 50% decline in population density as one moves away a kilometer from the city center as defined here, right? So that was 1975. 2015, this basically India cities became flat in the sense that there was only a 31% decline in population density as one moved 1 kilometer away from the city center, right? So this thing, one phenomenon that I noted was that the density gradients were very high and steep for very small cities, like those in the northern states that you saw, all the blue dots that you saw, right? This is also a blue dot, right? These are the red dots, which means that they were all very, very suburbanized. And you will find that Varanasi was Prime Minister Modi's electoral constituency in 2014. And that we found was the most suburbanized of all the Indian cities in 2015, based on the density gradient that we estimated, along with another city called Kolhapur in Maharashtra. That's also a very western state, very urbanized. And in Varanasi, there is a lot of highway infrastructure that has recently characterized this city. So, which basically explains why that is so suburbanized, because highways basically enable commuters to live further away from the CBD and travel to work from wherever they are, right? So robust highway infrastructure enables suburbanization. And in Kolhapur, Maharashtra, what we found was that um, the central city infrastructure was under a lot of stress as per some recent studies. So that possibly explains why the city in a very urbanized state, suburbanized during the period. So now, what we next try to understand is the suburbanization of households in the largest cities from 1991 to 2011. Now, the reason why I showed you Mill's two-point gradient technique was that these are calculated for 1991. This is from my paper published in Regional Science and Urban Economics in 2007. So these are all calculated and these are estimated, right? Estimated using the data intensive technique that I showed you, and these are calculated using the using Mill's two-point gradient technique. So you find that Delhi's household suburbanized, as may be seen in a decline in its absolute value. And Mumbai, we could not really estimate this for 2011. And Chennai, that also suburbanized households. This is households, right? Kolkata, Bangalore, Hyderabad, everywhere is the same story, right? That they all suburbanized undoubtedly. And this is remembering the caveat that in 1991 they were calculated, whereas in 2011 they were basically estimated. Now, I hope that the slides are moving. Now, these are the regional variations in the population density gradients in 1975 and 2015 in the cities of urbanized and high-income states and the BIMA-RUO states. So BIMA-RUO states, this is an acronym to refer to states in India that are backward, lagging, and slow growing. And incidentally, B refers to Bihar, BI refers to Bihar, M refers to Madhya Pradesh, which is in the center, MA, and R refers to Rajasthan. U refers to Uttar Pradesh, that large populous state that I showed you, where Varanasi is located, the most suburbanized, and O refers to Odisha. So these are all a set of backward lagging states in India. And interestingly, in Hindi, the word Bimar means sick, right? So it has been traditionally used to refer to these states. So we try to classify and understand the suburbanization pattern of urbanized states and Bimarao states separately. And this is what we found. And no doubt, the average density gradient of the urbanized states in 1975 was much lower, the absolute value, right? So they are much more suburbanized, right? The urbanized states, cities sprawled a lot more in 1975. And the same story in 2015 also, even further, 2015 also, like when you compare the Bhimarao states with the urbanized states, you find that the urbanized states were actually more sprawling in the sense that they were more suburbanized, and this is what you find. So one striking finding that we have here is that the urbanized high income states had their cities more sprawling, right? But we would have expected them to be a lot more compact because they're urbanized and they need land and they need to be efficient with the use of land. But that was not clearly the case, right? The urbanized and the richer states, they sprawled a lot more than the poorer states. Now, the next thing that we see here is employment density gradients, right? Employment. So, this is answering our second or third research question, whether employment is more or less suburbanized than population. So now we had only 18 cities here, all India. So what we did was we found that the employment decentralization, the employment suburbanization was to a much greater extent than population suburbanization. This is because the employment density gradient for these cities was only zero point 0.2 when compared to the population gradient for the 100 cities, which was 0.31. So basically, this means that employment density was declining only at the rate of 20% for every 1 kilometer away from the central city of every city. However, it is defined. And the most compact city in terms of employment suburbanization was this small town in this backward, slow growing state of Rajasthan. Now it's growing a bit more rapidly, but traditionally it has been growing, known to be slow growing. And the minimum, that is the most suburbanized in terms of employment, is in the national capital region. This is right next to, adjacent to Delhi, the capital, and it is Faridabad. And Faridabad is very unique in that it is characterized again by sprawling highways, right? So the national capital region is also very unique in that it has the best highway infrastructure in the entire country. So there is no doubt that Faridabad is the most suburbanized in terms of employment, because that enables employers to stay away, further away from the city, and make use of lower land costs, especially when manufacturing is involved. So I'll show you some interesting data pertaining to that. So this slide basically shows the spatial distribution of employment within selected cities by employment subsector, right? Now, what I find is that considering all the cities, on average, more than half of the total employment is concentrated within a 5 kilometer radius of the city center. However, within the last 5 kilometers of the city, last 5 kilometers radius of the city, on average, 30% of employment is concentrated. 30% of employment in other sectors. Other sectors are all the urban services like trade, commerce, retail, wholesale, services, and so forth, right? So those are all included in others, right? So I find that on average, so now making sense of this table, the first top panel basically shows the percentage of jobs within the first 1 kilometer radius of the identified city center. And for example, for total household industry workers, and only 5% of total household industry workers locate within the first kilometer of the city center, because these are presumably manufacturing, right? And you won't get the land, and you are polluting, so you won't really locate near the city center, right? Now, the bottom panel shows the share of employment in these cities within the last 2 kilometer radius of their city area, right? So here we find that on average, one fifth one fifth of the employment is in total household industry, and other workers, they are concentrated in the last 2 kilometer radius of the city, right? And there is also some peri-urban activity here, in the sense that more than one-third of agricultural laborers are located in the last 2 kilometer radius of the city. So on average, however, 30% of employment in other services, which means they're all the urban sectors, non-agricultural employment, is concentrated within the last 5 kilometer radius of the city. So this is the last 2 kilometers, whatever you're seeing in the table. But overall, that's what I found. So employment is suburbanized, but to a much greater extent than population suburbanization. So now, what did we find is the association of population suburbanization with various socio-economic and demographic factors, right? There is this famous paper by Miskowski and Mills, 1993, in the Journal of Economic Perspectives, and in which they provided an excellent survey of this literature. And basically the explanation of the post-war suburbanization of the United States is divided into two kinds of theories. One is called the natural evolution-based theory of suburbanization, which basically shows that as people's incomes increase, households would like to move out, consume more land, and suburbanize, right? And similarly, when highway infrastructure improves, commuters would like to would like to locate farther away from their workplace and then commute to the city back and forth, right? So that is the natural evolution or market-based theory of suburbanization, as it is called. And the second stream of explanations for suburbanization basically stems from the central city flight from blight. Right, central city flight from blight basically means that whenever central city property tax rates are high, public services are poor, the city is polluted, it's congested, and the traffic is too much in the central part of the city, households suburbanize in order to enjoy a better quality of living, right? So this equation that you're all seeing here, it includes both natural evolution factors of suburbanization, like the population of the city and the income of the city. These two are measures of the natural evolution theory. And we have a lot of variables which kind of represent the central city flight from blight. I'm sorry to use this, but it's a kind of pejorative connotation, but that's how it's called. So the lagged value of the population gradient from 1975 is used to explain the population gradient in 2015. And the literacy rate in the central city is basically used to indicate the central city vis-a-vis that of the suburbs, and unemployment rate in the central city, and the scheduled caste and the scheduled tribe population in the central city. These are they are socially discriminated against, like the African American population in the US. So they are used as a measure of a social discrimination against the population, whether or not people move away from them, and central city density in order to indicate the stress on infrastructure, and land use regulations in the city, most importantly denoted by the floor area ratio. And I've written a series of papers on this, but summarizing that, a high FAR means a relaxed FAR will basically make a city compact. That basically means this will have a positive effect on the population density gradient. So in the first stage, we estimated the population density gradient for each of these 100 cities. That is our BPJ, which you see here. And in the second stage, which is what this equation is, we try to understand what explains the suburbanization, considering the natural evolution factors, the central city flight from blight factors, and along with land use regulations. So, what did we find? Actually, the findings were actually not very interesting, in the sense that the urbanizable land actually, and the population gradient, the lagged value of the population gradient, were the only ones with the expected and the statistically significant effect on the population density gradient. This urbanizable land basically means that higher the extent of urbanizable land, lower is the population gradient, which means that the city sprawls a lot, which makes actually a lot of sense. So because if your urbanizable land, net of hilly areas, lakes and rivers and oceans, so the greater the extent of urbanizable land, the greater will be the extent of sprawl. That's what this basically means, and that is consistent with what we expect. And the lagged value of the density gradient has a positive and statistically significant effect, which means that a city's historical spatial distribution of population plays a very important role in explaining its urban form today, right? Which also makes sense. And this is consistent with a series of papers written on Indian cities by a number of authors. So that is one thing that I wanted to indicate. Now, what did we find in the focus group discussions? So when we did this focus group discussions, it was the peak of COVID, right, in 2021. So nobody would come in person. So we had a webinar where all the realtors, academic experts, and policymakers reflected on what really explains India's suburbanization. The academic view was that the hinterland of cities is a very cheap alternative for farmers and the rural unemployed to locate, and that's one reason how suburbanization occurs. And the realtor slash developer view was consistent with this, in the sense that there are a lot of disparities in real estate prices across the central city and the suburbs, which actually many authors have documented. And that's the reason why suburbanization occurs. And much as what the central city flight from blight indicates, there is a need for improvement in the quality of life with increased income. I mean, that's also what the natural evolution theory indicates. And the realtor view was that as people need more housing, the floor area ratio regulations should be gradually relaxed in cities, right? And however, one of the consequences that the realtors pointed out was that there are a lot of public services like solid waste management and sewage which need to be managed better. And that is what precisely what I will be showing you in the consequences when I discuss the consequences of suburbanization. I don't know how much more time we have here, but I will maybe take another 5 to 8 minutes if that is okay, Stephanie.
Yes, that
Okay.
sounds great. Let's open it up for some questions.
Yeah, let me just go through the last few slides I have here on the consequences. Is that okay, Stephanie?
Yep, I think that's great.
Okay, thank you. Thank you. So this is the access to solid waste management and let's see, this bar is closing it. Healthcare. Healthcare. The left panel is the access to healthcare and the right panel represents the access to solid waste management in Bangalore, right? So here, healthcare, the stars are usually the best wards. We ranked this based on a study we did earlier, a couple of years ago. So the stars here are basically mostly in the center, but there are some stars in the peripheries as well, which basically means that healthcare is more or less evenly distributed across the center and the periphery. Now, solid waste management, right? Solid waste management, the stars are mostly in the center, right? And what you find in the periphery are only circles, which are zeros, or triangles, which means that all these peripheries rank quite low on solid waste management. Okay, so that is one inadvertent consequence of suburbanization. This is taking the case of Bangalore. Now, this is taking the case of drinking water, right? So this is some ongoing work I'm doing with Kiran Seto at Yale and Bhartendu Pandey and others. And this is actually currently a work in progress. And this is a bit complicated. It shows the differences in coverage between tap water from a treated source minus the households who had tap water from premises. So within their premises. So this basically is a paradoxical kind of pair of public services which shows which households had access to better services like tap water from a treated source even when they did not have tap water within the premises. So here what you find is this dark shades here are the ones which had tap water from a treated source, which was greater than the tap water within premises, the extent of this access for households. And you find that primarily it is only the central parts of Bangalore. Again, this is Bangalore, the central parts of Bangalore that has better access to tap water from a treated source when compared to tap water within premises. And mostly the peripheries are all white, which means that the peripheries, I live somewhere here, so basically, we have only tap water within premises, but not tap water from a treated source, right? Okay, so that is one. And this is the same story. This is the differences in coverage of households between a piped sewer system and open drainage. Again, taking the case of Bangalore. So the darker shades are the ones which are well covered with a piped sewer system, and these whiter areas are the ones which are basically characterized by open drainage. And this is another South Indian city, Chennai. And you will find that the city center wards are this, and the central part of the city is mostly covered well with a piped sewer network when compared to the peripheries, which lack access to this and have only access to open drainage at best. And this is the distribution of tap water from a treated source and within premises in Chennai, which again shows better coverage of the central wards when compared to the peripheral wards. So this is another consequence of suburbanization, that only central parts are served better. And this is one other example with air quality, which basically shows the particulate matter in 2000, particulate matter 2005, and so forth, and population gradient 2015, population gradient 75, and so forth. The correlations are all negative between the particulate matter and the population gradient, which basically means that in more suburbanized cities with a lower value of the density gradient, the particulate matter was high, right? So that is what the negative correlation shows. And these are my last couple of slides. And The fact that richer cities sprawl more shows that the costs of sprawl there are less, but nonetheless, richer cities have to plan basic services, municipal services like water supply, sewerage, solid waste management much better in the periphery. And the FARs, the land use regulations of Indian cities, are not statistically significant in determining the sprawl. And I found the negative exponential form is a very good explanation of Indian cities' urban form in 2015 when compared to their urban form in 1975. And we have found that employment sprawls a lot more than population sprawl. And access to municipal services like water and sewage and solid waste management are most affected, and air quality also are most affected due to suburbanization. And these are some caveats of the work. Density gradient is only one measure of urban sprawl and suburbanization, and the global human settlements layer is not a local data set. It is, as I said, based out of the European Commission. So there are a lot of issues with administrative jurisdictions of municipal areas, and we need local nighttime data sets. And employment and household suburbanization are measured at a different level, the census ward level, than the population suburbanization, which is measured at a lot more minute grid level, kilometer level. And the employment sprawl is based on data are based on 18 cities only. And what are the contributions of this work? This is the last slide. And we treat suburbanization in India, which deserves a separate treatment from that of Asia or Europe or the US. And the approach of the research thus far has, I have found, has been only qualitative, at least in the Indian context, with the conspicuous absence of the standard urban model, which I apply to Indian cities to understand this. And we also use unique data from the global human settlements layer and state specific data sets to understand suburbanization at a very granular level. Thanks a lot for your attention, and I look forward to your questions and comments now. And Stephanie, once again, thanks a lot for this opportunity to present this work as part of the Glenn College Colloquium series. And congratulations to you once again. Thanks a lot.
Great. Thank you, Kayla. That was a wonderful, great presentation, really interesting. I see Connie came if you wanted to say anything, Connie, say hello. You're welcome to.
Yeah. Can I stop my share? I can't see Connie.
Oh, there you go. Maybe you can see her now.
Oh,
She's
yeah. Hi, Connie. Nice to see you. Nice to see you.
Thank you,
Thought she was
Carla.
on mute.
Yeah, and Chuck would be so proud of you and your research.
Yeah, I
Yeah,
miss Chuck. I miss Chuck a lot. I used to write all these
me
tidbits
too.
of updates. Yeah,
Yeah,
I can
yeah.
imagine. But
Y-
I'm delighted that you were able to fill in his shoes, and
Yes, yes.
I'm always amazed.
Good, good.
I'm
Very
always
good.
amazed by how well you do that.
Yeah,
Yeah, thank you. Thank you very much, Connie. Thank you.
sure.
And we probably have time for one or two questions. If somebody wants to either just come off mute or raise your hand, let's at least have one or two if there's folks with questions.
Stephanie, I can ask one. So thank you so much for this presentation. I sent this across in the chat. I was curious about how to interpret the number of observations in the table where you break out the proportion of employment that is in the periphery or the far parts of the city. So I didn't manage to write down the slide number, but if you share your slides again,
Yeah.
I can direct you to the table I have the
Yeah,
question
I
in.
understand what you mean. I understand because see, the employment suburbanization, as I said, was based only on 18 cities, all India, right? 18,
Yes, yeah, and
18,
in that part of the
And
table,
yeah, I know what you're asking because what happened is that, see, I was interested in the first kilometer of the employment concentration within one first kilometer of the city and the last 5 kilometers of the city and last 2 kilometers of the city. And there were some cities which were so small that we did not have a 5 kilometer radius for those cities. So there were only a few cities that actually fell into that bucket, right? So that's the reason why there are only 4 cities in the last row, if I remember what you asked, right? So
yeah.
we had only a very limited data set for doing the employment suburbanization. So that explains why the observations were too few in some of them. I did look at them. I did look at that. Yeah. Does that answer your question?
Yes, yeah, I think I'm just sort of thinking about how generalizable that like last few kilometers of the city is, and if there are ways that we all could think about measuring cities sprawl such that we could measure consistently across cities of various sizes, you know, that edge of the city. So this is not my area. I have some work on job seekers at a distance. So that's why I was asking, because often workers are not able to locate where all of the jobs are. I think you're suggesting something slightly different, that the sprawl of employment is actually greater than the sprawl of the city. So I was just curious about that sort of the edge of the city. But we can follow up another time. Thank you for your talk.
Yeah, thank you. Thank you very much, Ashley. Yeah, because if someone is thinking about a question, I can just try to answer this because see, the concentric circle that I drew, that is where the helpful called a circle where the radius would be the same, where the employment can be possibly spread. And actually, some of my earlier work, what I found was that employment was concentrated in the city center primarily in the retail sectors, banking, finance, insurance, and all that, right? Whereas for manufacturing, the household employment, household industry, and non-household industry, and all that were very suburbanized. So, which makes a lot of sense, right? Because manufacturing cannot be located in the center of the city. And similarly, mining, for example, I found that to be very suburbanized. Obviously, you cannot have mines in the center of the city, right? So I hope that makes some kind of sense to you.
Wonderful. Well, we are out of time, and I know it's very late there, so we really appreciate you staying up and talking with us and sharing your work. But hopefully, people can follow up
Yeah,
with you directly if they have questions, and
yeah.
we'll keep the conversation going. So, thank you so much again
Okay.
for presenting.
Yeah, thank you. Yeah, thank you.